So today we'll be starting the last topic of this course, that is structures. So far we have seen primitive data types and derived data type. Primitive data types are like int, char, float, and so on. What is the example of derived data type? Arrays, right? But arrays is one kind of derived data type. If you remember, I also mentioned that it is a homogeneous derived data type. Why homogeneous derived data type? Because switch off these lights. Because all the elements of the array should be of the same type. That is, array can have only all integers or only all characters, all floats, and so on. It cannot have a mix of some integers, some characters, some floats, and so on, right? But there may be situations where we may need a mix of these, some integers, some characters, some floats, as one data type, as one unit. Like I'll come to that example. So such a data type, derived data type, that is a heterogeneous derived data type. Example of that is struct. Okay, so why do we need this kind of a data type? Let's imagine, I mentioned this example earlier also. Let's imagine I want to store the data, all the details or as many possible details of a student as possible. So there are many students, but each student has different kinds of details like name, age, address, roll number, marks in a course, what all courses or which year that student is in. So there is a lot of information related to each student, right? So one way is I have different arrays for each student. Say, suppose this is student 1, student 2, student 3, and so on. Now, each student has all this information, say name, age, roll number, address, and so on. So each student will have this. Now, one way of storing this data is you slice it horizontally. That is, I will have an array of names. Okay. So in this array, first element tells me the name of the first student. Second element tells me name of second student. Third element tells me name of third student, and so on. Again, I have another array to store the age of all the students. So first element tells me age of first student. Second element tells me age of second student, and so on. So I have separate arrays. One array to store the names of all students. Another array to store the ages of all students. Another array to store the roll numbers of all students, and so on. So here, in this scenario, it is I who is mapping, who is seeing the correspondence across arrays. For a computer, there is no correspondence between these arrays. Each array is an independent array. It doesn't know that the name which is there in the first array of the first element is or belongs to the same student whose age is there in the first element in the second array. It doesn't know that all these first elements in all the arrays belong to the same student. They may belong to different entities altogether. There is no concept of one entity for the computer. They are just arrays. That's it, right? And also, it makes it quite difficult for us to handle this data in case there are any changes. Suppose some student leaves, some other student joins. Now, I need to delete the data of the student who left from each array. I need to go to that particular element, that particular array, delete that particular element from that array. Say some fifth student 5 left. So I need to go to array 1, delete element 5. I need to go to array 2, delete element 5. in each array, I need to go and delete that element. And again, if some other student is joining, I need to add that student's data in each of the arrays, right? I need to split that data and I need to add it in each of the arrays. And imagine no student left, but a new student is joining. Now, earlier I thought say 100 students are there, but now 101 student is joining. I need to increase the size of each array. Right now, array size maximum is 100. Now I need to increase the size of each array. How to do that? We have to create a new copy all the previous elements from the previous array to the new array, and then add the new student's data in that new array. So here, this is not a natural way of thinking for us. For us, a student joins and a student leaves. It is not like a name joins, name leaves, age joins, age leaves, address joins, address leaves. It's not like that, right? Conceptually, student is an entity. Student is a being, one unit. So it is more natural for us if we can treat a student as a unit, and all the data related to a student, if we can store it at one place as a unit, that is more convenient and more natural way for us to deal with the data, right? So here, our focus is more on the object rather than the data type. Why are we splitting them into different arrays? Because an array is a homogeneous data type. A name is one data type. Age is another data type. Roll number is another data type. So I am focusing on the data types and worrying about how to store this data. I'm not focusing on the object. I'm not focusing on the semantics. I'm focusing on the syntax, right? But what is the natural way? The more natural way is for us to focus on the semantics. Semantics means meaning, study of meaning. So a student entity, as one unit, is more meaningful to us than an array of names as one entity, or an array of ages as one entity. That is not one entity, right? It is just some array of ages or array of numbers. Grouping all ages together doesn't make sense to me, but grouping all the information of one student at one place makes more sense to me, right? So rather than splitting this data horizontally, a better way would be if I can store this data like this, if I can slice this data vertically, if I can store each student's data as one unit. So this is one student, this is second student, this is third student, and so on. All this data is together. Each student's data is together. Now, if I want, I can create an array of these students. Rather than creating an array of names, creating an array of ages, creating an array of addresses, I can first group them as a structure. Now I can create an array of structures. Array can be of anything. Only thing is it should be homogeneous. That's all. There is no rule that array should be only of primitive data types. Array can be of derived data types also. Like we have array of arrays, right? Multidimensional arrays are what? Array of arrays. Matrix is array of arrays. 3D matrix is array of arrays, and so on. So in that case, what is that? Each array is having an array as element, not an integer as element, but an array as element. Similarly, each array can also have a struct as element, a structure as element, an entire object as element. So I can create an array of objects, not necessarily just an array of integers or array of characters. I need not limit myself to create only primitive data type arrays. Okay, so now this is more meaningful, more natural way of understanding the data, storing the data, accessing the data, and at the same time, I'm also storing all the students' data in the form of an array. So that information is together. Okay, so a structure is the first step towards object-oriented programming. So what is the difference between object-oriented programming and the programming which we did so far? In the programming which we did so far, data type, it is all data type driven and data type centric. But object-oriented programming is object-centric. You will use data types there also, but the way of thinking will change. You will think more in terms of objects. Like you will think of a student as one unit, right? But if you use only data types, then you need to think of, okay, which feature is integer, which feature is character, which feature is string, which feature is float. You will be thinking along those lines, which is not a natural way for us to do. A more natural way for us to deal with is with an object directly. Okay, there is an object. This object has these features or these attributes. There is a student. A student has all these attributes: name, age, height, address, roll number, all these things. So we are treating object as one unit now. So object centric programming is object oriented programming. That's a different style of programming. This is the beginning. Struct is the basic beginning point for object oriented programming, but still it is quite different from a class in object oriented programming. But the idea is, I mean, the root of that idea is here. Like we are creating a class of a student. We can have different classes, right? You see, a student is a different object. Student will have some attributes. We can also take an institution as one object. Institution will have, like university, like Mahindra University will have other kinds of attributes. It's like it will have employees, it will have students, it will have buildings, it will have hostels. All these are different attributes of this university. Similarly, there can be other universities, University 1, University 2, University 3, and so on. But their overall structure is similar. They will have a management, they will have students, they will have infrastructure, all this. So structure of a university is different, but structure of a university is same, and different universities have different values for those features. And I can also have a structure, say for an animal, maybe for a dog or a cat. So each object structure is different. Okay, this is a class. It is like in philosophy, we distinguish universal from an instance. That is, suppose I have treeness. Treeness is universal, which is present in each tree. Why are we calling each tree with the same name? Because each tree has treeness in it. Why are we not calling this table as tree? Because it does not have treeness in it. Why are we not calling this building as tree? Because it does not have treeness in it. The universal or the class or the concept of a tree is present in each of its instances. Okay. Similarly, say chairness is present in each chair. So we have a universal and we have instances of that universal. So this physical spatio-temporal object is an instance of the class called chairness. This chair, that chair, that chair, each chair is different. Each chair is an instance of chairness. Each tree is an instance of treeness. Similarly, each integer variable like x, y, z is an instance of integer class. Similarly, each float variable f1, f2, f3 is an instance of float class. Similarly, a student structure, when we define the structure of a student, that is the class of a student. And each student variable s1, s2, s3 we can define or we can declare and then define. That is an instance of student data type. Similarly, each university instance u1, u2, u3, that is an instance of the class struct university. Okay, if any of you had used classes in Python, you will understand this. You first need to define the class and then you need to define an object belonging to that class. Okay, so struct is like a class. But each class is different. Chairness is one class, treeness is another class. So chairness is a different data type, treeness is a different data type. Similarly, struct student will be a different data type. Struct university will be a different data type. Struct chair, struct animal will be a different data type. So struct itself is not the data type. Struct is just the keyword. Struct student, this entire thing is a data type. Because student will have a different structure, university will have a different structure, animal will have a different structure, chair will have a different structure, right? So these are all different data types. You will get a better clarity as we move on. So first, let's look at some examples. And before we move on to an example, you see primitive data types, they have two components. If you remember, one is declaration, second is initialization, right? So what are primitive data types examples like int, char, etc., right? And declaration example, suppose I say int x. Initialization means, so I can say x equal to 5, right? Two steps. Either you can combine them or you can separate them, but conceptually they're different things. Okay. So you declare a variable and then you initialize it. Either you do both the things in the same step or you can split them into two steps, but conceptually they're different. Okay. Similarly, struct, it is basically a user defined data type. So here example is struct. In user defined data types, these are second and third steps: declaration and initialization. What is the first step? Yeah, exactly. Definition. Because you need to define each struct. You need to define the structure of a student. You need to define the structure of a university. You need to define the structure of an animal, right? That structure is not inbuilt. It is like inbuilt functions versus user defined functions. There are some inbuilt functions like printf, scanf. You don't define them again. You just use them, right? But user defined functions like we define various functions like squaring a number or swapping two numbers or sorting an array or finding the sum of an array, different kinds of things. You define these functions. So you have to first define them and then use them, right? Similarly, these data types, you have to define them. Otherwise, there is no inbuilt structure for a student. There is no inbuilt structure for a university, right? So you can't directly use any data. Those data types are not present. You have to define them. Only after defining, you can declare different instances of the data type and initialize those instances, right? So definition is an additional thing in all user-defined things. User-defined data types, user-defined functions. User-defined means what? In the user-defined word itself, there is definition. You are defining it. So you define it and then use it like a normal data type or normal function. Okay. So let's look at an example. So there are these three steps, right? Definition, declaration, and initialization. So we will look at each step. So first, struct definition. So let's look at struct student. Suppose that student has name. Name is what data type? It's a string, right? It's a character array. Let's say max, say 30 characters are there in the name. And age, it's an integer. And say height, that is float. And roll number, we call it ID. And let's say that is max 10 characters. Okay. And struct, this is how you define a struct. At the end, you should put a semicolon. Okay. So this is like any student will have these features. So this is like the class of a student. I mean, this is like the student class. It is not about this student or that student. It is like the structure or the template of a student in general. This is how you define a student. Okay. Now, what is the data type here? This entire thing, struct student, is the data type. Like int, char, etc. Struct itself is not the data type. Struct student is a data type. You can define a new data type later, struct university, that will have a different structure. Again, struct animal will have a different structure. Struct chair will have a different structure. So struct student together is one data type. Now you can create instances of this data type like int x, y you do. Similarly, struct student s1, s2, s3. You can do like that, right? Struct itself doesn't mean anything. Struct means structure. Structure of what? Struct student is one structure. So that is one data type. Struct animal is another structure. So that is another data type. Okay. So each struct some name. That Entire thing is a data type. Okay. So this is definition. Now let's look at declaration. So second step is struct declaration, or we can also call it as instantiation. This is not initialization, this is instantiation, which means for a universal or for a class, we are giving instances. We are creating instances of that class. That's all. This is not initializing. We are just instantiating that class. Okay. So how to instantiate? It's like now any normal variable, like you do int x, y, z. You can just say struct student S1, S2, S3. That's all. Okay. Like int x, y, z, you can say struct student S1, S2, S3. From now, struct student is like any data type. All right. Now we can combine both the steps, definition and declaration. All right. So these three steps, definition, declaration, initialization, we can do them also separately, or we can combine all of them, or we can combine two of them. Anything like in primitive data types, declaration and initialization, you can combine them or you can split them. Similarly, in user-defined data type, definition, declaration, initialization, you can combine all of them or combine only two of them or split all of them. So we will look at all the different combinations. Right now we saw we defined and declared separately. Now we will combine them. So 1 and 2. Struct definition declaration. So how to do that? Let's take this. Paste it here. So here struct student definition is there. So before I close this semicolon, I can declare the instances like S1, S2, S3. So this is the structure, definition, and these are the instances. That's all. So you are defining and declaring at the same time. Okay, fine. Now, third step, initialization. Struct initialization. So initialization means what? Assigning values. Assigning values, because I just declared instances S1, S2, S3, but each student's name is different, each student's age is different, each student's ID is different. I need to specify those values, right? What is student 1's name? What is student 2's name? What is student 1's age? What is student 2's age? I need to give values. So that is initialization, right? So that we need to do. So what attributes did we list here? Name, age, height, ID. So let's say some first student S1, S1's name, say I want to, so how do I access S1's name? We say S1 dot name. Suppose I want to say a student 1's name is Ravi. So is this correct? No. Why? That is one way. What is another way? There is a function. Exactly. You remember? This is array. I mean, this is string. Imagine you have two strings, A and B. Can you just say A equal to B if you want to copy B to A? No, you should not do that. If you want to copy B to A, you have to use string copy A, comma B. Similarly, this is like A, this is like B. So if you want to assign this value to this, it is like copying this value to this, copying one string to another. So you cannot use assignment operator. You have to use string copy function. Okay. So I want to say first student's name is Ravi. Copy string, that string value into this variable. Okay. But other variables are simple. S1.age, say maybe 17. S1.height, maybe 5.8. Now ID is again a string, right? So again I have to use string copy. So string copy S1.id, say some ID 123. Okay. So this is how you initialize the values, each member at a time. Fine. Now we saw how to combine definition and declaration. Now we will see how to combine declaration and initialization. Like I said, out of the 3 steps, you can combine any of them or two of them or all 3 of them, or just give all the 3 steps separately. Now we will see how to combine declaration and initialization. So 2 and 3, that is struct declaration initialization. Okay. So while declaring itself, you can initialize. Like if you remember, for an array also, while declaring you can initialize, or you can do them separately. You declare the array and then initialize each element separately, right? Similarly, here we can declare and initialize at the same time. How do we do that? Struct student S1 equal to all the values in order: name, age, height, and ID. So you need to give the values in order. Here you are initializing during declaration step itself. All right. Now, what if I separate them? Can I do this? I declared and then I initialized. Can I do this? Go back to the example of arrays. You declare an array and then you try to initialize array like this. Will it work? No. Same thing. Here also it won't work. In array, this kind of thing will work. While declaring itself, you are initializing. That will work. But if you are separating them, then you cannot initialize in this format. You cannot give the entire array elements in one go. You have to declare. You have to initialize member by member. Similarly with a struct, if you want to initialize all the elements at once, you need to do that with the declaration step itself. If you want to initialize all the members at once, you cannot separate it from declaration step. If you separated it from declaration step, then you have to initialize member by member, like we did here. Here we initialized one member at a time. This is fine. This is separate from declaration. S1 was declared earlier. I am initializing it here. But I am initializing each member at a time, one member at a time. That will work. But if I try to give it as an array like this, it will not work if you give it as 2 steps. Okay. So this won't work. All right. This is very similar to arrays. Okay. Now let us try to combine all the 3 steps: definition, declaration, and initialization. Right. So what did we see? So here, So these three steps, first we saw each of these three steps separately. Okay. Then we saw 1 and 2 together. Then we saw 2 and 3 together. Okay. Now we will see 1 and 2 and 3 together in one go. How to combine all of them. Okay. So struct, definition, come declaration, come initialization. So how to do that? Let's copy this. So first you define the student structure and then you declare an instance of that student and then you initialize it in the same step. So whatever values we gave here, you put them here. Okay. So this student is defined here and an instance of that student is declared here and that particular instance values are all initialized here. You can declare other students also, say S2, S3. You need not initialize them. It's up to you. You just declare them. You can initialize them later. But if you initialize them later, then you have to initialize one member at a time, one attribute at a time. If you are initializing during this step itself, then you can give it like an array. But if you are initializing it later, then you have to give each element separately. Okay. So you can mix and match. You can do it partially. You can do it fully. You can separate these steps. You can combine these steps anyway. It is up to you. It doesn't matter. All right. Clear? Any doubts? Okay. So definition, declaration, initialization. If you understand the difference between these three concepts, you will understand this very easily. Okay, so you can combine them. You can combine 2 steps at a time. You can combine all 3 steps, or you can split all 3 steps. Okay, yeah. Now let's look at another example. We all know coordinate geometry, and on a coordinate plane we have points, right? Each point has how many coordinates? 2, x coordinate, y coordinate. Okay, now suppose if I want to store some 100 points, 100 2D points, how do I store? Suppose you don't know struct, what will you do? Yeah, different ways. One is I use a single array to store 200 elements. Okay, it's like x1, y1, x2, y2, x3, y3, and so on. That is one way of storing. Another way is use a 2D array like a matrix x1, y1, x2, y2, x3, y3, and so on. Right? Or another way is 2 arrays. I mean, you can again do it like this also, x1, x2, x3, y1, y2, y3, either like a matrix or 2 arrays. One array for storing x values, another array for storing y values. Multiple ways. But what is the most natural way of storing is to treat the pair of coordinates as one unit. Okay? And to have an array of these pairs. Okay, so each pair is like one unit, right? So each pair can be treated as a struct. Each point can be treated as a struct. Now, if I want to store many such points, I can create an array of all such points, right? So let's look at an example. Yeah. So suppose I say struct point. Okay, so what will be the members? X and Y, but I need to give the data type, int or float. Let's say float. This is a real plane. Okay, so I can say float x comma y, or I can say float x float y. Anything is fine. All right. So now let me use it in the main program. So I say int main, and so now what is the data type? Only struct or struct point. This is the data type. Now I can create instances of this data type. Okay. So struct point. Let me create 5 points in different ways. So point P1, say its values are 4, 1, x and y. And point P2, I will not initialize right now. I'm just declaring it. Point P3, I will initialize slightly differently. I will say dot y equal to say 2, dot x equal to say 3. So here the order does not matter because I am naming the attributes. Which attribute is given which value I am naming. So order does not matter. But if you are not naming the attributes, order matters, right? And let's say P4. In this case, suppose I know only the y coordinate value. That is also fine. Dot y equal to 10. X coordinate value I may know later. I will initialize it later. Right now, whatever data I have, I am filling it. Okay, and say P5. I don't know P5's values. Okay, so all this will work. In this case, order matters. Okay, in this case, order does not matter. All right. Or let me say P5 equal to say -2. I'll just give one value. Okay. And some other point I will just declare it and leave. Okay. So in this case, since you did not specify whether it is x or y, it will automatically assign this to x because x comes first. That's all. It is like an array. If you remember, when I'm assigning, if my array size is much larger, if I have, if my array size is 10 and I am specifying only 2 elements in the RHS, those 2 values will be assigned to the first 2 elements in the array. The remaining will be initialized to 0 by default. Similarly, in this case, if your number of members are larger and if you are giving less number of members, they will be assigned to the first few members. That's all. But if you want them to be assigned to specific members, then give their names like this. In this case, I know y value is 10, not x value. So I specify dot y equal to 10. So that this 10 is not automatically assigned to x. I want this 10 to be assigned to y. Okay. So these are the different ways in which you can initialize during declaration itself. And all these 3 ways, this one, and not this. These 2 ways, actually these 2 ways. These 2, they're examples of designated initialization. Which means you are designating the values to specific attributes. This attribute takes this value, this attribute takes this value. If you are not giving dot x, dot y, etc., it will just take the order. That's all. Okay. Now let's try to initialize the remaining. So P2 we have to initialize, and in P4 we have to initialize x. In P5 we have to initialize y. In P6 we have to initialize both. All right. So how do I initialize P2? P2 dot x equal to some value, maybe 1. P2 dot y equal to say -1. Okay. Similarly, P4, can I initialize like this? Dot x equal to 2, dot y equal to 10. No, this will not work. If you want to do this, you should have done it during declaring P4 itself, during declaration step of P4 itself. Right? So this is not allowed. If you want to get the value, you assign it. So P4 dot x equal to 2. And again, P5 dot y may be 0. P6, I don't know, so I will scan it from the user. So scan P6 dot x. Similarly, scan P6 dot y. Can I say scan P6? No, it will not work. Scan P6 will not work. You cannot scan an entire structure. You cannot print an entire structure because there is no format specified for that. What do I say? Percentage S, percentage V, percentage F. What do I say? It can have some integers, some floats, some characters. There is no one format specifier for an entire struct. I need to go element by element and I need to specify the format specifier for that element and I need to either scan it or print it, right? And then I can say print, increase the page size a little. I can say print. Suppose I want to print all the points values. How do I print? Do I just say print P1, P2, P3? No, I cannot. I have to print element by element. So I have to say print P1.x, P1.y, P2.x, P2.y, and so on. Okay? I cannot say print P1, P2, P3. This will not work. Okay? So let's quickly code it and see. So first I'll define struct point, semicolon at the end of struct closing bracket. So we can say float x, float y. All right. And in the main function, define struct point p1 equal to say 4,1, p2 I won't initialize here, p3 I will initialize as dot y equal to 2, dot x equal to 3, and p4 I will initialize only 1, that is dot y say equal to 10, and p5 I will just give one value, no attribute name, and p6 I will not initialize at all. All right. Now p1 dot x equal to say 1, p1 dot y equal to say -1, and sorry, p2, this is p2, and p4 dot x equal to say 2, and p5 dot x I will not initialize right now. We will see. No, p5 dot y I will not initialize right now. I will scan p6 attributes. What should I write here? Sorry, p6 dot x and p6 dot y. That's all. Ampersand. Okay. And now I'll print all these points. I'll say P1 equal to percentage point to F, percentage point to F line, P1 dot X, P1 dot Y, right? Let's do this for the remaining also. 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. Okay, let's see. It is waiting for me to give P6 X and Y coordinates. Something, say 5 and minus 8. Okay, so P1 is 4 and 4 comma 1, P2 1 comma minus 1, P3 is 3 comma 2, P4 is 2 comma 10, P5 is 7 comma 0. I just said 7. It initialized Y to 0 by default. Okay, and P6 values whatever I gave, 5 and minus 8. Okay, yeah. So yeah, so this is how you define, declare, and initialize a structure, its instances, and the members of each instance. Whatever members are there inside a structure, those are called members or attributes. Anything is fine. All right. I'm getting constant murmuring sound. Please maintain silence. Yeah. So if you want to initialize all the elements, all the members at a time, you have to do it during the declaration step. If you are doing it at any other place, you have to do member by member. That's all. No other way. Okay. Now, suppose I want to define some other point later. Like in the sense, say now I want to define struct point P7. Okay. Suppose some code goes here. Again, I want to define some other point, struct point P8. Now, everywhere I have to type entire struct point. I don't want to do that. I want to give an alias to the struct point. Say I just want to call it point, so that later I can use point P1, point P2, point P7 while declaring. Right? I want to do that. So there is a way to give alias to anything, not only a struct name, but anything you want to replace. Suppose you have a very large name, you want to replace it with a small 2-letter word. For that, you use something called type def. So type def, it's like string S1, S2. So S2 is an alias for S1. Okay, so let us see how it works in the case of a struct. Type def struct student, or I mean struct point. Let's take struct point. We can say just point. Okay, so in this case, let's not say just S1. It is like what do we say? Some keyword or some unit. Here struct point, entire thing is one unit, right? So this unit, I want to replace it with just the word point. Okay, so this is how you sort of say that. So from now, whenever you want to use struct point, you just use point. That will be treated as struct point. But the actual data type is struct point, not point or only struct. It is struct point, but I don't want to type that entire thing every time. So I'm just giving a shortcut. That's all. Another way is, so now once you do this, you can say point P1, P2, and so on. Okay, so this is equivalent to struct point, whatever. So struct point P1, P2. Okay. Now another way is, while declaring the struct itself, while defining the struct itself, you can give the shortcut. You can give the alias. So how to do that? So let me move this to the next page. You can directly say type def struct point float xy. Okay, this is the structure. Here you can say point, and then you can say point p1 p2. Okay, so this is saying for this is the alias. Okay, anything is fine. So here point is not an instance of struct point because you have type def here. If you didn't have type def here, if you just had struct point and then this definition and then some name here, that will be an instance of struct point. Okay, but since you had type def here, this is only alias. This is not an instance. Now, if you want to create an instance, you can say point p1 p2. Okay. So now this is equivalent to struct point p1 p2. Okay. All right. Any doubts? Okay. All right. So let us stop here.